Assalamu alaikum class. How are you all? 7th class, this is your S.st lesson related to geography book, unit number 1, chapter number 1. So, the first concept which is coming in our geo book is about plate tectonics. It is related to the earth layers, how the earth is made and how the plates are made there. I am giving you one resource video about this topic. You have to listen it carefully so you can learn about it.
Let's get started. The first thing we need to know is this. The outer shell of the Earth, which I gave an example of being the magic shell on a scoop of ice cream, this solid outer crust of the Earth, we call it the lithosphere. It's actually broken into pieces that we call plates. You see them here. You can call them lithospheric plates, you can call them tectonic plates, or simply plates. But this is the solid outer part of the Earth that we live on. Some of the plates are all oceanic crust, some of them are all continental, and some are a combination of the two. That's going to become important. Keep in mind that we do have these two distinct types of crust. If you look at the gray here, this is our continental crust. It's thick, it's made of the rock granite, it's not quite that dense, only about 2.7 grams per cubic centimeter. But if you look at the dark gray area under the oceans, that's the oceanic crust. It's very different. It's much thinner, more dense because it's made of the rock basalt. The density of basalt is about 3 grams per cubic centimeter. Keep in mind that information can be found on your Earth's interior chart in your reference tables. Now, that crust, whether it's oceanic or continental, along with this kind of orangey section called the rigid mantle, those two together are what make up our lithosphere, the solid outer shell of the Earth. Keep in mind that beneath that is kind of a gooey, plastic, partially melted bubblegum layer called the asthenosphere. And so the plates that we live on are actually floating on the asthenosphere beneath. Now down in the asthenosphere, that melty, gooey, bubblegum-like rock is actually able to move. And it moves because of a process known as convection. Essentially, convection says that hot material becomes less dense and rises. And then when it rises, it cools down, becomes more dense, and sinks. And what we end up with are these rising and sinking currents called convection cells in the mantle. Those end up being the machine, the force that is driving the motion of the plates. So in this diagram, we have a type of boundary called a divergent boundary, where the plates are literally being ripped apart by the movement of the convection beneath. Keep in mind, this convection takes place in the asthenosphere, right below the lithosphere. So let's take a look at a map of the plates. Okay, there's a very similar map in your reference table, which we'll see shortly. But for the moment, take a look. You notice that the plates, some are very large, some are a little bit smaller, but they're all moving. And what that means is that there's lots of action at the places where plates meet. For example, that's where we find all our earthquakes, shown here with pink dots.
As we have seen that there are the spheres and plates of the earth. Now moving toward the next step, there are the plate boundaries, which they will explain now.
Tectonics comes down to the fact that things happen when two plates interact with one another. So we need to know what those interactions look like. And it really boils down to 3 types of interactions, 3 types of plate boundaries. The first is known as a transform boundary, and that occurs when plates slide past one another, as seen by these arrows. We also have convergent boundaries, where plates collide, and divergent boundaries, where they drift apart. You should be familiar with each of these and the kinds of things we see at each of them. So let's go into some examples here. Okay, I'm going to be alluding back to this chart. This is a map in your reference tables that shows plate boundaries. So keep that handy as you're continuing to learn about this. Let's start with transform boundaries. So these are the boundaries where plates slide past. The lithosphere, floating on top of the asthenosphere, is being driven by convection currents, which is causing them to slide laterally past each other, right past each other. And so right along that boundary in the middle, you get a lot of pressure built up, a lot of grinding of the plates, which is often released in the form of earthquakes. earthquake risk of cities like San Francisco and LA. Let's go back to our reference table for a minute here and see that the transform boundaries are shown down on the bottom with this symbol, shown in green here. There's a couple of them, not too many, but what type of crust is involved. For example, we see different things happening when it's oceanic crust colliding with oceanic crust, as opposed to when it's continental colliding with continental, and so forth. And so we have a few different types of convergent boundaries. The first type we call a subduction zone, and as you can tell by this little animation here, this happens when continental crust on the left collides with oceanic crust on the right.
Now we'll read about it. The theory of plate tectonics states that the Earth's solid outer crust, the lithosphere, is separated into plates that move over the atmosphere, the molten upper portion of the mantle. This was all about the molten upper portion of the mantle. Oceanic and continental plates come together, spread apart, and interact at all boundaries over the planet. So, 7th class, you will learn about this by heart and you will write it on your rough copies for memorizing it. Thank you so much.